Hi there. It's nice to be with you today at EMMSAD. And our topic today is exploring modeling method, in this case, the non-functional requirements framework, towards the development of socially responsible software. This is joint work from York University and PUC-Rio, and the first author is Luiz Marcio Cysneiros. I'm Júlio César Leite from PUC-Rio, and I'm going to be presenting today. Our goal is to make software trustworthy. But why software needs to be trustworthy? Because software is everywhere. Software is impacting our life and the life of the planet. And we are being seeing more and more the application of artificial intelligence in software. Talking about ubiquity everywhere, Alexia is a very nice example of a software produced by Amazon that can interact with homeowners, with people at their place, at their home, controlling the smart TV, doing some other chores of home management, but also poses a question of how intrusive is this software in your home. We have the example of self-driving cars, which will be a possible future where cars will be driven by software, but this brings out the concern about how safety this will be, how this will impact insurance, in the insurance industry, as we have to know who is to blame for if there is an accident. We have now massive social connection to the times that we live by now. And we heard from the news that some of those softwares have security breaches, and those security breaches may bring some issues on privacy. We have law enforcement using AI pattern matching software for finding, matching people in scenes with pictures captured from the internet, and this may also pose a problem of false positives. So how about the impact of software in our lives? We understand, and this seems to be a common concern, that as systems are mission critical, we have less trust in those systems. So there is a lack of trust in those systems as they get more complex. Here we have a result from a poll made in Canada, and I think it shows an interesting results. While 70% of Canadians are comfortable with apps making appointments, 73% are comfortable with home management systems. But as we've seen before, there are issues there. But there is a difference when we talk about software driving cars. Only 39% of Canadians feel comfortable with this. So this is a representation of how software impacts our lives. And why AI? Well, AI is software. And we've seen a growing use of AI, new technologies, with machine learning being a key one, with and within the Internet of Things. So it's affecting our lives as well. So we note from a work from Microsoft Labs that a group of researchers wrote, the reference is right here, as exactly as in the paper, and we got a sentence from there. And it says, machine learning models are software artifacts derived from data. Again, come to our point, AI is software. So this new software that we are seeing coming out of different companies and new companies, they include new technologies of AI, and they have a large social impact because they change paradigms. And they also have legal implications. So how to embrace this new scenario? The scenario where software is everywhere. Software impacts our lives, and we have seen more and more use of AI. So we have to build trustworthy software. So software must behave in a social responsible way. So how we make software in such a way that it behaves in a more social responsible way? Well, Cysneiros had this insight into looking at corporate social responsibility, area of 20 years where the business community looks into policies that a company may have that brings more social responsibility. Those policies are policies in the sense of being more transparent to the customers, being more ethical in doing the business, being more responsive to customers. And what they found is that companies that follow those policies of corporate social responsibility have more loyalty from their customers, do have repeated business, and have a future of more purchase intentions. So corporate social responsibility brings trust to their customers. So this analogy with corporate social responsibility brings a possibility of having software that has social responsibility, right? So the idea is, let's build software that will lead customers to trust the company that is using the software and also the company that has built the software. So the software itself will be more trustworthy. But one of the important things, not only to maintain, regain, or achieve new markets, is that in the future, we're going to have a high demand for socially responsible software. Our second research insight is using non-functional requirements as a way of using or reusing the ideas of corporate social responsibility towards socially responsible software. We base the work on non-functional requirements on the NFR framework, work from the Toronto group cited here, and NFRs are represented in this framework as soft goals. The soft goals are refined and they are interdependent and they are operationalized. Soft goals are considered different from hard goals because soft goals are satisficed, contrary to goals which are satisfied. So this is very important to point. So a soft goal is satisfied. That means we don't have a very clear-cut measure to measure the satisfaction of a soft goal. The soft goals are, as said, interdependent. They are operationalized, and those interdependence are represented in the software interdependence graph, the language of the NFR framework, and they have contribution relationships, which shows the impacts of the different soft goals upon others and from the operationalizations upon the soft goals. Okay, so here we have an example of the NFR framework. And here we have two qualities, usability, energy efficiency, or two non-functional requirements. You see that they are refined. Usability is refined in allow selection and ease of use, energy efficient and use natural light and light only use rules. Okay, and in yellow here, we have a goal to achieve, which is the adjust light, and three operationalizations. How those operationalizations reflect upon the qualities. And you can see I have the option of doing manually by a control panel or automatically. And we have the cross links here representing the impact. So here, from manually to allow selection, we have a help, a plus. From control panel to allow selection, we have a make, plus plus. From automatically to allow selection, we have a break, minus minus. Control panel to user use, we have a hurt, minus, and so on and so forth. Our second example deals with usefulness, a quality that helps to achieve better usability. And For usefulness, this was refining a sure comprehension of information, sure applicability of information, and improved cognition. But this will be, if you see at the bottom or the bottom right part of the figure, you're going to see different operationalizations like use online, use offline, use desktop, use PDA, use tablets, and you see the relationships, the impacts, the contributions of those choices upon the goals that we want to achieve, as well as the soft goal that by the end of the day help to have a better usability. Having the two insights that we've seen before, how we operationalize bringing those ideas of corporate social responsibility towards our goal. So we went through the scholarly literature on corporate social responsibility, focusing on trust, and tried to find which qualities were mentioned on those works that were more frequent, that were related to trust. And we found 5 most frequent mentioned qualities: ethics, privacy, security, safety, and transparency. But we had done a previous work on self-driving cars, looking at the context of self-driving cars from the perspective of transparency. And what we found that an important concept was legal disputes, so compliance with norms, laws. From the non-functional requirements that we got from our elicitation using the literature, we are able to produce the SIG, the software interdependence graph, relating the 5 non-functional requirements that we found from the literature together with the concept, with the non-functional requirement of compliance, of legal disputes, and relating them to trust. As you see, the non-functional requirements here contributes in a help relationship to trust, but also they contribute as we need to deal with legal disputes. So this is the main result so far. Concluding, as we see and we believe that the non-functional requirements are the driving force for socially responsible software. And from this research as of now, we are able to capture those illicit non-functional requirements, and we believe that at least those NFRs are mandatory for building socially responsible software. But we need to continue. We see in the future that we have to elicit other qualities for socially responsible software. We have to persist the illicit information in SIG catalogs, that means repository that capture and maintain the non-functional requirements knowledge. We may be able to add existing operationalizations, such as, for example, this work by Salmitri and colleagues on security, privacy, and trust. When we also aim to develop methods to help researchers and practitioners to build more trustworthy software anchored on non-functional requirements. And also, we are targeting the connection of software ethics regarding of these legal implications. That is it for now, and thank you very much. Please read the paper. We are here to answer any questions. Thank you very much.